All right, welcome everyone. Okay, this is notes for 8D notes, and again, still an exponential function. So let's go ahead and begin. As you see, there's not a lot of slides here. It's really a lot of notes. So you just want to keep up with that. And again, we went over this in class, so it should be a review. If you missed class, then you can kind of catch up and see what we did. So I'm gonna go ahead. So what you're gonna be able to do here is you can identify the following from when you graph an exponential function. So x and y intercept zeros in behavior, increasing, decreasing, horizontal asymptotes, continuity, and domain and range. Now keep in mind, if you have a graphing calculator, you really want to be using it because it makes the graphing so easy. Now, characteristics of exponential functions here. This part is, a lot of this is the same for every function, so you just got to really memorize it, okay? So, domain, they write it real simple, but basically it's all real numbers. This is x such that negative infinity is less than or equal to x, which is less than infinity, positive infinity. Okay? So domain is always all real numbers, doesn't matter. Your range is always y is greater than 0, so all positive real numbers. There are 3 points that are on every exponential parent function. 0, 1, 1b, the b comes from here, and then negative 1, 1 over b. Again, the b comes from here. Okay? Your x-intercept is always 0, 1. Your y-intercept is always 0, 1. Doesn't have an x-intercept because it never approaches the x-axis. It approaches but never crosses. Okay? So y-intercept is always 0, 1. X-intercept, there is none. If b is greater than 1, f of x equals b to the x goes up to the right. So in other words, it does this. Oh, sorry, I didn't do that. It does this, okay? And you're going to see that, okay? And also, it's always increasing, and it demonstrates exponential growth. This t doesn't really belong there, so don't worry about that, okay? Now, if b happens to be between 0 and 1, can't be 0, can't be 1, f of x equals b to the x. This goes down to the right. So in other words, it does this, okay? It is a decreasing function, and it demonstrates exponential decay. Growth and decay are something you use in science a lot. Okay, now f of x equals b to the x is a one-to-one function, and it has an inverse function. HA, horizontal asymptote. The graph of every exponential parent function approaches but does not touch the x-axis, so the horizontal asymptote is y equals 0, because that's the x-axis. If you say x-axis, I'm going to be okay with that too, because I know what you mean. Okay? So either the equation y equals 0 or the x-axis. All right. Now, a few more notes. So for exponential functions, a basic exponential will have the horizontal asymptote at the x-axis or when y equals 0. This means the graph will approach the x-axis, but it will not cross it. A vertical shift alone or with a horizontal shift will change the asymptote, and a horizontal shift alone does not affect the asymptote. So, just for stuff you need to know. Okay, let's keep going. Now, here, if you don't have a graphing calculator, you're going to have to plug this in. But what you guys should be doing here is let's just plug it in. So let's just hang on a minute. I'm going to pause this and get my calculator together, so just give me a minute. Okay, I'm back. I have the Casio graphing calculator up, but I'll verbally walk you through TI if that's what you have. So basically, if you're in there, we're going to go to the graph menu. So we're going to go to 3. Okay, and then we're going to put in our function. It's y equals 2 to the x. So you're going to want to do 2 caret key x. Okay, and then I'm going to execute, and then I'm going to tell it to draw. Okay, I'm not on the standard window, so I'm going to fix that. Okay, yeah, that's all crazy. That's okay, because I use mine a lot. So now I'm going to draw. So now, there is your graph. That's what it looks like, and that's what I mean by it increases, and it goes up to the right. So now let's go back to our notes, because I just wanted you to see how that works. If you're on a TI, what you want to do is you go to your y equals, and then you just type in 2 caret key x. Caret key is this, and you guys have that too. And then you're going to hit enter and tell it to graph, and bam, you're going to get the same thing. Again, I'm on a standard window, so if you're curious, negative 10, positive 10, scale of 1, negative 10, positive 10, scale of 1. Just so you know. Okay, so now let's go back to our notes. And so when you look at your graph, again, we've established it look like that. Okay, now if you don't have a graphing calculator, you need to do this by hand, okay? So our domain, we've already talked about, all real numbers. That's what it looks like when you use the notation. Range, y is greater than 0. X-intercept, we know there is none. Y-intercept, 0, 1. Asymptote, y equals 0 or the x-axis. Now, go back to our graph. Is it increasing or decreasing? When you look at this graph is increasing. Okay? And then zeros, remember, zeros are where it crosses the x-axis. It doesn't cross the x-axis, so there's no zeros. And then our end behavior, you have to tell me what happens both directions. So if we look at our graph, there it is. As x increases, y increases. As x decreases, y goes to 0. Okay? That's basically what that means. Okay? So let's look at another one, and you'll start to see it's the same thing. So when you do y, 3 raised to the x power, we'll go and do that again. So let's exit. Now I want to do, I'm actually going to put it on top just so you can see it, but 3 raised to the x power. Okay. Okay, so you see that both of them are there. So let me go back here. I'm going to unselect this one and just click that. So it's still there, but it's just not selected. Now I'm going to tell it to draw. So look, it's closer in, so it's still the same thing. Sorry about that. Okay, and then let's go back. So our domain again, all real numbers. Our range, y is greater than 0. There are no x-intercepts. Our y-intercept is always 0, 1. Asymptote is always y equals 0, the x-axis. That one's still increasing. There are no zeros. And notice our end behavior is still the same. As x increases, y increases. As x decreases, y goes to 0. Okay? Now, the next one that I want to show you is what happens when this is between 0 and 1. We talked about that. So let's put that in on the calculator. Okay, so it's y equals 1/2 raised to the x power. And the way you want to put this in, just so everybody sees that, we're going to go back in. Okay, I'm going to do this. I'll just put it in on this one. Again, the first one's not selected. So I'm going to do parentheses, and then I'm going to do 1 fraction key 2, close my parentheses, and then I'm going to raise it to the x power. Okay? If you're on a TI, you're going to do the exact same thing. Put that fraction in parentheses. Okay? Yours would be parentheses 1 divided by 2, close parentheses, caret x. And then I'm going to tell it to draw. Notice it's now coming the other way, so it's a decreasing function. Okay, so it's doing this. Okay, so again, our domain is all real numbers. Our range is y is greater than 0. There are no x-intercepts. Our y-intercept is still y 0, 1, as still x-axis. It's a decreasing function now. There are no zeros, but our end behavior, as x, since it's decreasing, as x increases, y goes to 0, and as x decreases, y goes to positive, or y increases. That's what that means. Negative would be decreasing, positive infinity is increasing. Okay? And then they give you another one just like this with the same thing. So you're going to graph it again. Again, all real numbers. Y is greater than 0. X-intercept, there's none. Y-intercept, 0, 1. Asymptote is y equals 0. It's again a decreasing function because this is a number between 0 and 1. Okay, there are no zeros, and your end behavior is the same. As x increases, y goes to 0. As x decreases, y increases. Okay? Okay, now, this is just a review, so let's make sure you got it. So is an exponential function with b equals 5 increasing or decreasing? It should be increasing, which means it's exponential growth. Here, if b is equal to 1/5, it should be decreasing, which means it's exponential decay. What's the asymptote? Horizontal axis, or y equals 0. And then name the 3 points on every function. 0, 1, 1b, -1, and 1 over b. you don't have a graphing calculator, knowing these 3 points will help you do the graph. Okay? Guys, that's it for this one. So make sure you're doing B, 8B, and 8B, and I'll see you on the next video.